to another problem session. So this one is also a JEE problem. So this is also coming from JEE Advanced paper 2, and this question number 6. It's like a too thick a pen. I want to maybe get the black one a little bit thinner. Okay. All right. So this is we have two mirrors. We don't know what is this distance, but this guy has a focal length f on the identical mirrors, and a glass slab of thickness t and 0. So right, there's this a glass slab that's put in the middle like that, and there is a source of light right in the middle. So it's not the center of these guys, okay? It looks like center, but don't fool yourself. So this source of light is going to have a, because you have two mirrors, you can have an image in one mirror, or it can have an image like this from reflection from two mirror. You can even have reflection from three reflections, 4 reflections, so on and so forth. But it says that there are some of these condition that image will form, either virtual image, okay, a real image will form right here at S. It doesn't tell you what kind of image, just image will form at S. So all right, so S is object and image at the same place. One of those, you might say many images will form because of parallel mirror. So the condition we have to find is what should be this D that will make the final image, one of the image being on this, or the second image, or third image, or fourth image. So it's there are 4 choices here. So it seems like if you're just looking at the choices, these guys are similar. So it seems like it corresponds to one of the images, and these guys are similar, so they correspond to another of the images. So basically we have to look at 2 images from the way the answer is placed. We don't have to find all the images, okay? All right, so we need to have a little bit of strategy to handle it, and drawing rays here would be pretty hard because it's too thin here. So I'm going to have to scoot over here, and slab I'm going to draw a wide slab, okay? And this would be the axis. Pretty cool. So this is the original place. So let's pick a ray and also make it thinner. Let's pick a ray from here. I'm gonna pick a ray that is a little small angle here like this, and it's going to not continue in that direction, but is going to widen out because this n0 is greater than 1. Okay, so we'll just say is greater than 1. I don't know if the problem said n0 is greater than 1. it just, from the way it is written, it seems like it's more than air, right? So optically denser than air. I'm just assuming that. So that it's going to go wide like that. The normal here is going to be parallel to this. Going to be hard to draw. Normal is, and if you, so here is, it will form, and let's see, it comes and we would like it to return the same path, then there will be real image form here. So the image, this object and image will same. This ray will go back like this and back like this, if that was the case. Well, when it will reflect, because if this was the radius of curvature, okay, if this was the radius of curvature, then that will be right. If this is the radius of curvature, then we would expect this to be the case, right? And that should be equal to 2 times f. If this is the case, then I expect it to hit that at a normal, and so this is supposed to be the center of this thing. Then it happens. Let's see what, this is one image, so let's figure out okay, so if we, this designated curvature, and here to here is t over 2, and let's call this x, and let's call where it strikes that distance, call it y. So if you look at these triangles, this was, say, O, and let's call it some Q, let's call it let's call A, and B, this is Y, and this is X, this is T over 2. This is going to be equal to the angle, incidence angle, and this is going to be reflected angle, but the refracted angle is n equals to 1, so it's going to be tan theta I will be y over t over 2. Tan theta r will be y over x, and angle being small, we can call it sine theta I, and this will be sine theta r. So now n0 sine theta I equals to nr sine theta r, which is 1, and this is n0, and so n0 or 2 over t equals to 1 y over x, and y cancels out. That gives x equals to t over 2 n0. This is good this we'll be able to use this again. Okay, so we really don't need to do this kind of calculation. Okay, one more time, but this would be enough. Okay, so what do we have? So we got this guy. So if we can find this guy out, so this is the center. From here to here we want. Here to here is from this, that's the R, which is same as 2F. So if you do this guy, this will simply be from here to here is T over 2, and this part is X. So this is T over 2 minus X. So we have that distance D should be 2 times sum of these guys, right? Distance D should be 2 times R plus T over 2 minus X. Okay, so you have 2 times 2F plus T over 2 minus T over 2 and 0. So this becomes 4F. T common, 2 cancels out. 1 minus 1 over n0 t. So this is not n0 minus 1 time t, but it's 1 minus. So this is correct. So A is correct. All right, that's one using this idea that when returned to the same place. So of course, this is one mirror. So this is image from one mirror reflection back at, oh, this was point S, source, back at S, source S. So this is our one way the image can form. Another ones can be go and reflect back in here, right? So we should do the second one. Maybe that's B or D will be from there. So what I mean is, so we not just reflection from one mirror, and okay, we'll just do this, and so we'll have go like this, go like this, and if you want to keep it symmetric, then we want it to go parallel to the axis. So this is the oh man, this is so hard to draw. This is the axis, so we want come to the parallel to the axis. If it comes, then it will just repeat it, right? So it will come here, and look, it's going to have to come that place that was X earlier, and it will come like this, and then it's going to just repeat that way. So a distance X is going to be coming towards it, if it comes towards it, I mean, if this reflection is it's exactly like this, then appear. So let's look at this other direction ray, and these two. So it's appearing to be coming through here, but it will go through here. So also real image, right? It's going to form at that point. This just basically this right condition is same as left condition. Well, the only thing you have to figure out this time, instead of coming right back, it's becoming parallel. That means this distance from here to here is not r but just f. So this will happen if this distance is f. If this distance f. So we already know this distance will be t over 2 minus x, which is t over 2 minus t over 2 and 0. So now we have the whole distance d should be f plus t over 2 minus t over 2 and 0 2 times this, right? So this f plus this guy, let's call it x prime, f plus x prime, this x prime. So this f plus x prime. So it just multiplies 2f plus t minus t over n0. I think we can take the t out. 1 minus 1 over n0 t. So this should be the second answer. Let's look at this second answer. So that answer is B. So that's how we get A and B. And of course, both of these can't be true. So this is definitely wrong, and this is definitely wrong. We don't have to go check them for wrongness. All right, it was actually a good problem. Took a little bit of thinking. So this is the image from one mirror reflection, and the other one is an image. This image is from two mirror reflection. From reflection from both mirrors. So these are the rays that know they had one reflection through both the mirrors. But since this is a completely closed, there will be no other way. If you keep the distance, one of the two distances, then you're gonna form this mirror. Of course, if you have some other distance, you're gonna get a whole bunch of images. Okay, just like I don't know if you know, you should try to solve this one, a very similar problem where you use plane mirror and another plane mirror, and you put an object over there, source over there at distance a, and this distance say is d, and you look at all the images that you're going to see, whether you look in that direction or you look in that direction, you're going to see a whole bunch of images. Okay, so that's another kind of problem that you should practice. Okay, that's it. I'll see you in another problem session. Bye now.